Welcome to our second webinar on cylindrical roller bearings. In this episode, we will take a closer look at single-row designs and special variants of cylindrical roller bearings. We will begin with the structure of the bearing designation and then take a closer look at the E design. After that, we will discuss cage designs and the different materials used. Next, you will learn about additional design features, from internal clearance to special designs such as retaining grooves. As always, we will finish with a brief preview of the topic of our next webinar. The designation of a cylindrical roller bearing has followed a clear, standardized system since the 1930s. Each designation begins with the letter N, which indicates that the bearing is a cylindrical roller bearing. This is followed by additional letter combinations describing the design type. For example, whether and in which direction the bearing can accommodate axial loads. Next comes a numeric code defining the bearing dimensions. Finally, the designation is completed by suffixes, which provide additional information. For example, about the internal design, the cage, the internal clearance, or special versions. Let us look at a specific example. NU 208. The first part, NU, describes the design type. NU means that the bearing has two fixed flanges on the outer ring, while the inner ring is designed without flanges. This allows the bearing to compensate for axial displacement of the shaft and makes it particularly suitable as a non-locating bearing. The second part is the number combination 208. It defines the nominal size of the bearing and determines the dimensions according to DIN 623. The 2 indicates the bearing series or diameter series, and therefore the size range in which the outer diameter and the width are located. The 08 identifies the bore diameter. Specifically, this means that bearing 208 has a bore diameter of 40 millimeters, an outer diameter of 80 millimeters, and a width of 18 millimeters. The designation is completed by the suffix EC/P. EC stands for an optimized internal design incorporating more and slash or larger rollers and with modified roller end/flange contact. P denotes a glass fiber reinforced P A66 cage, roller centered. In the 1960s, the so-called E-bearings were developed. Due to a higher number of rollers, they provide an average increase in load capacity of about 35%. The letter E stands for a reinforced and optimized internal design, for example, through more or larger rollers and improved contact conditions between the rollers and the flanges. Because the rollers are larger, the so-called F dimension becomes smaller. The F dimension refers to the outer diameter of the inner ring and can vary depending on the design. This is particularly relevant when the bearing is installed without an inner ring. Versions without the E design are relatively rare today and are mainly found among Japanese manufacturers. For this reason, the F dimension should always be checked in the catalog of the respective manufacturer. Now we come to the cages. The cage separates the rollers, keeps them at a defined distance from one another, and ensures uniform guidance. In this way, it directly influences the friction behavior, the permissible rotational speed, and the temperature development in the bearing. Sheet steel cages are one-piece designs, can withstand high temperatures, and are resistant to synthetic oils and greases. In addition, their low radial height provides more space for lubricant. One-piece brass cages can be guided either on the outer ring flange or on the inner ring flange, and therefore offer precise guidance on the respective ring. They also stand out due to reduced friction and cooler running. Two-piece brass cages, on the other hand, are roller-guided and represent the common standard design, but they are heavier and generate more friction than the one-piece version. Polyamide cages are lightweight and cost-effective, and have therefore become the standard in many sizes. Their disadvantage lies in their limited resistance to temperature and oil. An important selection criterion is the internal clearance, which describes the internal freedom of movement between the rollers and the raceways. Cylindrical roller bearings are often supplied with normal internal clearance CN or with increased internal clearance C3. CN is not marked on either the bearing or the packaging. C3, however, can always be clearly identified by its marking. During operation, the internal clearance changes due to temperature, interference fits, and load. If the clearance is selected incorrectly, this can lead to increased friction, higher wear, or even premature bearing failure. The correct selection of internal clearance is therefore essential for reliable operation. Another version is cylindrical roller bearings with a tapered bore. They are pressed onto a tapered seat on the shaft and therefore sit particularly securely. The decisive advantage is that pressing the bearing onto the taper allows the internal clearance or a defined preload to be adjusted very precisely. This allows the bearing to be optimally adapted to the respective application. There are also several design variants that simplify installation and operation. One of these is bearings with a snap ring groove in the outer ring. This groove allows the bearing to be actually fixed in the housing using a retaining ring. This saves installation space, simplifies mounting, and reduces installation time. In the bearing designation, this design is indicated by the suffix N. Another variant is bearings with retaining grooves. These prevent the outer ring from rotating in the housing when a loose fit is used. Versions exist with 1 or 2 retaining grooves, with 2 grooves typically arranged offset by 180 degrees. These designs are particularly helpful when the bearing is not firmly seated in the housing, but still needs to be reliably secured. Depending on the manufacturer, these versions are designated, for example, with N1 for 1 locating slot notch and N2 for 2 locating slots notches. Cylindrical roller bearings without an inner or outer ring offer a particularly compact solution. In bearings without an inner ring, the housing directly guides the rollers. This allows larger shaft diameters to be used and therefore increases the stiffness of the shaft. In bearings without an outer ring, guidance takes place directly on the shaft. This enables a very compact design, good heat dissipation, and high radial load capacity because the available installation space is used optimally. Both variants offer great design flexibility and are primarily used where the runways can be hardened and ground directly on the shaft or in the housing. In the next webinar, we will focus on cylindrical roller bearings for high loads and give you an overview of other important features. For example, seals and multi-row cylindrical roller bearings. If you would like to explore the topic in more depth, we would be pleased to welcome you again to the next webinar. Thank you very much for your attention. We look forward to seeing you in our next video. Thank you for your attention.